Yeah, we're going to take some notes. So I checked what we have left to do for Unit 3, and we have to do one big task, which we're not going to try to tackle today. Big, long word problems with systems that'll be probably later this week. And then we also have to do nonlinear systems. And so I'll show you what I mean. I plan to start class by just showing you what this is all about. But anyways, we have to do systems where they're not just lines, and we're not going to do any 3x3s for the rest of this week probably. So that might be good news for some of you, because I know some of you don't really care for that. But we're going to be doing 2 equations, 2 variables, but what changes is that now they're not straight lines. So that warm-up quiz you took, the 2x2 systems, these are 2x2 systems, but they're not linear. So that's the whole gist of today. So these are technically, I Googled it because I've called them other things in the past, but they're actually, anyways, today's the 28th. They're actually called mixed systems. And the definition of a mixed system is a system where like there are different kinds. Generally, from what I could find, not that we have to call them that, but one of the equations in the system is linear, like a straight line, and one of them is nonlinear, like a circle or an ellipse or a parabola or a hyperbola. These are all ones that you'll have a look at here today. So that's the gist, is we're trying to figure out where does a straight line cross a non-straight line. And so I decided that I would just go straight to Desmos and just show you, because I think going into this lesson, if you kind of have your head around what's happening, then you'll kind of have a better idea as to like behind the scenes what's going on. There's a lot of algebra we have to do, a lot of basic skills and solving quadratics and stuff, but I want you to have like a behind the scenes peek at it. So here's an example of a nonlinear system, a mixed system. You can see that one of the equations is x squared plus y squared equals 13. That's the graph of a circle. We won't really, you talked about that in geometry, FYI, but we won't really get more into these. These are called conic sections until if you decide to take pre-calculus, advanced math, then we'll do a whole unit on conic sections. But like a circle is a type of a conic section, and it's got an equation with x squared and y squared in it. And then, of course, the second one is just linear, y equals negative x plus 1, straight line. You've been graphing those since like 8th grade. So you can see that it crosses in multiple points. And that's what we're going to search for, is not just where do the 2 lines cross, but rather where does a line cross through a non-line. And this is one possibility. Here is another possibility. This is the red graph is what we call a hyperbola, and the blue graph is again a straight line. And so what you can see is that there's not going to be a crossing point as we head up this way, but there is a crossing point right here. And so in a case like this type of a system, we would only find one solution. And then the other type of system you're going to see today is just a standard, like if I did I'm just making these up. I decided I didn't really care what they looked like. But if I had like x squared minus 4, that is the graph of a parabola, right? I think you're somewhat familiar with those. We'll do a whole unit on parabolas at some point. I think it's after this, so don't worry about that. And then if I had another equation like 1/2 of x minus 1 or 2, you can see again that there are multiple crossing points, right? And that's the definition of a solution to a system, is where do they coincide? Where do they exist at the same time? So we're going to be searching through those 3 different types of systems, one with a circle and a line, one with a hyperbola and a line, and then one with a parabola and a line. And our job will be to find, using algebra, we're not going to use graphing. We can use Desmos as our backup plan, which is fun, but it won't be our primary mode of attack. Like our primary mode of attack is to do a lot of algebra, a lot of basic skills stuff, and then find the solution points that way. And one fun thing to do as you work through your assignment is I say fun. Who am I kidding? Gratifying maybe is to do the problem yourself algebraically And then to verify that you're doing it right, go to Desmos. You guys have all been to Desmos before. And you can just type the functions in and then with your own eyeballs see that the solutions are what you thought they were. It feels nice when you find them using behind the scenes algebra and then verify them using graphing because this takes all the heavy lifting off of us. Desmos makes it so we don't have to graph lines and graph. It does all of it for us and we can just use our eyeballs. It's quite nice. So I have 6 examples for you today. I have 3 of each flavor. I don't know if we'll get through all 6, but I did them in a very particular order. So there's like, I think I did parabola, hyperbola, circle, and then parabola, hyperbola, circle. I guess I was repetitive with the order that I put these in. So anyways, let's get to how to do this. By the way, the method that we're going to be using is exclusively substitution, which I'll refresh you on what that means. But remember that substitution is the one where we get a variable by itself. So let me just, if you don't want to write this part down, you're fine. But like if I gave you like y equals x plus 2, and then I gave you like 3x minus y equals 4. This is just a very simple linear system. But if I gave you this, you'll remember from a while back that with substitution, our job is to get one of the variables by itself, and then I like to box it up. And then do you remember what we do with that? You put it in the other problem in place of y. The variable that's by itself is the one that's about to get substituted out. So this y that I'm pointing at steps out of the way, and in its place goes the contents of the red box. So like here, we would have 3x minus empty space equals 4, and then into the empty space goes x plus 2. And then we solve the equation. Ours are going to be more complex than this, but the general flow, the vibe of how do you do substitution is that you get a variable by itself, box it up, stick it in the other problem, and then solve whatever equation you get. Does that ring any bells? You took a quiz on it like 3 weeks ago, or I don't know. I think it was before Christmas break when we did 2x2 systems. So it's been a minute, but that's the gist. So let's get to it with a mixed system where they're not both just straight lines, because you know that we've done that, been there, done that. So first one is y equals x squared minus 5. That's the graph of a parabola. Anytime you have y equals x squared, any type of x squared, it's just a parabola. Okay, it could look like this. It can look like this. It can look like this. So it can be skinny, fat, upright, pointing down. Okay, but just know that that's what regular y and x squared, that's the relationship that they create, is that parabolic shape, okay? And our other equation in the system is y equals x minus 3. So you see it's a mixed system. We have a quadratic and a linear, and we're going to see where they cross. Not that they always cross. I'd made sure with these examples, I think I did, that they all actually have crossing points. You could see that if you had a parabola that went like this and a straight line that went like this, they have no chance of ever crossing, right? And we would see that through like imaginary solutions, but I don't think that's going to happen to us today. You know, ours are going to go through just kind of normally. So anyways, let's get to it. So as far as substitution is concerned, you kind of have your pick. This is an interesting substitution scenario because if someone says get a variable by itself, you're like, it's already done twice. So you get to pick. The bottom line is that if y equals this, right, and y also equals x plus 3, let's pause for a second. Would you guys all agree, and I don't want to move on until you do, would you guys all agree that the red boxes have to equal each other? For real? Okay, that's really important. If y equals something and y equals something else, then the something and the something else have no choice but to be the same thing, correct? So we're going to substitute. A more standard way to put it would be to say I'm going to put this in place of this y, right? So the resulting equation would say x squared minus 5 must equal x minus 3. And then we go back and we're going to have a little review of factoring today. So if that's not your favorite thing, well, let's put a silver lining on it. You get another chance to practice. So we're going to be factoring a bit, quite a bit. So there's a quadratic equation. Do you guys by chance remember how to solve a quadratic equation? It's been a while. What's that? Oh, yeah, we don't need the quadratic formula, quite frankly. And I did verify. I think again, if I made a mistake, we'll probably kill that example. I don't know. We'll call an audible, but I didn't want to have to use the quadratic formula. You'll remember that some quadratic equations can be solved just by factoring. We don't need that negative b plus or minus the square root thing unless unless the numbers call for it. You got it? We actually want to move. This is going to come back from the past. You have all learned this from me. It's just like I said, I forgive you if you forgot because it's been a hot minute. These are the ones where we actually move all of the stuff to one side and set it equal to 0. Because a quadratic isn't about separation. That's a linear equation where we separate. A quadratic is we pool everything onto one side and then we factor if possible.
Is it by group?
We don't even need to use grouping. We don't even just watch this problem go, and I'll see if maybe any stress you're feeling is alleviated here in about a minute. Let's take everything and move it to the left side. And the reason I say the left side is because we should always want our x squared term to be positive. And if we move x squared, then we wreck him, right? So let's leave x squared right where he is. Let's pull the positive x over next to him, but his new name is minus x. And then we also have to add the 3 across. And what's the minus 5 plus 3? Right. And what we have now is a really standard quadratic equation. So I kind of knew there'd be some bumps in the road today. And one of them is that we're a little rusty, undoubtedly, on factoring. Now, we did a whole unit on factoring back at the beginning of the year, but that was like 4 months ago. So this is just a standard quadratic. We don't need grouping. We don't need A, B. This is just standard double parentheses factoring what multiplies to make this and adds to make this. And so we know that there's going to be an x here and there's going to be an x here. What do we know about our signs? Yeah, I mean, there has to be one of each. And the deciding factor is what I just circled in yellow. Remember, and I know we're rusty. If the back number is a negative, then the numbers literally have to be one of each because whatever they are, they multiply to make -2. And you can't do that with 2 negatives or 2 positives. So we know that if it's factorable, it has to go like this, right? And this is the part where we just get in there and there's really no magic trick to this. You just go in and say, well, how can I make this work? And what would the numbers be? Yeah, and we need them in that order. We need the 1 with the positive and the 2 with the minus because remember that when you check those 2 multiplication problems with the green connectors have to add, their answers have to add together to make what's in the middle. And in this case, what's in the middle is minus 1x. And sure enough, the 2 in the middle make plus 1x. And the 2 on the outside make minus 2x. And when you add those, you get minus 1x. So we know that our factoring was successful. We knew it was going to be a 1 and a 2. It's just that we had to lock in on the signs to make sure that they added correctly. So because this isn't just a factoring problem, it's an equation and we have to solve it. What solution or what x value do we get out of that right there? No. Yes, it's a negative one because we have to ask ourselves what makes it equal 0. And what makes x plus 1 equal 0 is if x is -1. What makes this one equal 0? Positive 2. Now, ordinarily in our past existence together, this is where we would have stopped. And we would have said, okay, those are the solutions to an equation. But we have to not lose our focus. We're not just looking for some x values. We're looking for points on the plane where 2 things are crossing each other, right? And points consist of x coordinates and y coordinates. So the fact that x equals -1 is pretty cool, but it's not the end all. Like it just means that there is a point named -1 comma something where the line and the parabola coexist. And the other one, again, not the be all end all, says that there is a point named 2 something where they coexist. How do you suppose, in all your experience with math, how do you suppose we can complete that yellow and green puzzle? Like what the yellow one, for example, how could I find the other half of the yellow? Plug it in, and you can actually plug it into either one that you want. That's the thing is if these equations are actually coinciding, you've seen this before with equations that it's going to work in either place. All I'm looking for is a y value. And this equation says, I'll give you one. Just change my x into whatever you want. And then this one says, I'll give you one too. So it doesn't matter where you put it. So like, let's say that you put it where this purple arrow is pointing right there. Basic math. If you put your -1 in there, what's -1 squared? 1. And what's 1 minus 5? -4. And you're like, well, what if I had picked the other equation? Well, check it again. Same thing, right? That's the essence of a system, is that if it's true that at one place, it ought to be true at the other place. Otherwise, something's gone wrong. And -1 minus 3 is again -4. Point being, it doesn't matter which equation you pick. And then let's check it for 2 also. It doesn't matter which one you pick. What are you going to get if you put 2 in place of x? It doesn't matter. Choose this one. It's easier. What's 2 minus 3? There you go. So we would say that the solutions to this mixed system are the 2 points in this purple box. And this is where when Monday or when Wednesday tomorrow comes and we're working on our own, this is where I would encourage you. And you can be dishonest. There's always technology that can allow you to be dishonest in math class. It's always there at your fingertips, but don't be dishonest. Like, you've done the work. And what's nice now is to go to Desmos and type the 2 equations in and just verify that it's legit. So like, I can go to Desmos, and in the first box, I can type in, you don't have to type y equals if you don't want to with Desmos. So like, my first equation was x squared minus 5. And my second equation was x minus 3. And then it's just sort of validating then to look at the graph and go, nailed it. Like, check it out. We have a parabola and a line. And sure enough, that point right there is what we thought, 2, -1. And that point right there is -1, -4. Okay, so we have a lot of examples to go. So just make sure you guys pick it up. Okay. Makes sense so far? So that's just a nonlinear and mixed system. We found the solutions and we're done. All right, let's try a different flavor. Like I said, they're not all going to be like that. So I was very careful to make sure that we don't just do like 5 of the same kind. So for this one, we're going to have this and this. And this is not a lesson on conic sections, but I did sort of hint at this earlier. What is the top one if you graphed it? It's a straight line, right? X, Y, no exponents. It's just a boring straight line. Does anyone by chance remember what the bottom one is? It's not. If there's a plus, then it's an ellipse like a circle. If it's a minus between the x squared and y squared, it's what we call a hyperbola. It's like 2 opposing sort of parabolic-y sort of things. So this one is a straight line and a hyperbola. But honestly, at the end of the day, you don't even need to know that. Like, the idea is we're going to do algebra here. So, all right, so this will be a little bit harder. And by a little bit, I mean a decent amount. Okay. So what's the first thing we notice about this? No one's by itself, right? And so what was nice about the last one was we had y equals blah, y equals blee, and we just set blah equal to blee. Like, that was easy. So our mode of attack, I can't think of any better way than this, is to get y by itself in the top equation. If you asked me to do this problem 100 times, I would do it this way every time. Correct. Y equals moved x, so negative, still positive, so plus 7. So this is going to feel more like the substitution that you're used to from the olden days. And I'm going to do what I always do. It doesn't matter what level of math it is. I feel the same about substitution, whether it's 9th grade, 10th grade, 11th grade. I'm going to put a box around this. I've always done my boxes. Big believer in that. And now what I'm going to do is I'm going to take that box and I'm going to plug it into the equation that I did not use to make the box. Quite specifically, that little red box is about to be replaced by the big long red box. That's substitution 101. So watch out. There's a basic skills test coming up right around the corner. So we'll have to pause here because there's going to be some stress. So let's look at it first. This step is not stressful. This is just following directions. We're going to put x squared minus awkward void squared equals 7. That's substitution by the book. And what's going to go into that awkward void? Negative x plus 7. I knew coming into this morning that this would be 5 minutes, maybe potentially, that we need to spend. Does anyone in this room by chance remember how to do that? It's not, I will just say this before you want, don't let it come out. It is not x squared plus 49. That's criminal. Like, does anyone, if you know the process, it's something we call square, square, multiply, double, by the way. If you know the process, then you would know the answer. Does anyone want to volunteer what you think the answer to this is? How about this? I'll tell you this. It's x squared minus 14x plus 49. Right? Do you remember that? Do you remember square, square, multiply, double by chance? Let's take a look at this. Now, first off, let me show you the bailout method. Bailout method. This is old school. If you don't remember what I'm about to teach you, square, square, multiply, double, you can always bail out. What does it mean to square something? Yeah, so quite literally, if you panic on a test, say next week or whatever, we take a quiz and you're like, oh, I don't remember square, square, multiply, double. Okay, then just do old school algebra 1. You just take negative x plus 7 and you multiply it by a copy of itself, another negative x plus 7, and you old school multiply this out. There's no way you've gotten to this level in this school without me specifically, and maybe Mr. Manlove having taught you how to multiply polynomials together. This will require four multiplication problems. What is negative x times negative x? Positive x squared. Okay, 1 down, 3 to go. We connect everybody to everybody. There is a shorter way to do this, and that's the square, square, multiply, double. But now this is our bailout. What is negative x times positive 7? Negative 7x. But we haven't connected everybody to everybody. There's still this positive 7 right here where I'm moving my pen. He's like, I got to multiply by those other homies too. So now if we take this 7 times this negative x, what do we get? Another minus 7x. And finally, if we make the final connection, positive 7 multiplied to positive 7, we get positive 49, and then we simplify. So when I said to you that the answer was x squared minus 14x plus 49, there were some kind of confused looks like, what are you talking about? Everyone knows where the x squared comes from. Everybody. You're like, well, duh, because you square that. Easy. And everybody knows where the 49 comes from because duh, you square 7. It's this mystery man in the middle. So I'll show you the shortcut way because you're going to be doing quite a bit of this. Not a ton, but quite a bit. And the shortcut is this. We all agree. I don't want to move on till you do. We all should agree that x squared came quite simply from squaring this, correct? And we all agree that 49 came quite simply from squaring this, correct? Good. So if we agree on both of those things, the question becomes, well, where did that mystery man come from? Well, here's the trick. Take red guy times green guy. This will work 100% of the time. Multiply them together. What do you get? Double what you just said. That's what goes in the middle. That's called square, square, multiply, double. Okay? There comes a point in our existence together where you'll hear me say that quite a bit. Square, square, multiply, double. Square, square, multiply, double. Before we go back to the other problem, let's practice this skill until it becomes simple. Let's do it again. X plus 5 squared. What's the first answer we know? X squared. What's the last answer at the back that we know? Plus 25. Again, everybody knows that. In the middle? No, not 20. 10x. Multiply red by green. What do you get? Double what you just said, 10x. That's how you square, square, multiply, double. I mean, if you're some sort of masochist, you can always write it out the long way like I did before. But square, square, multiply, double is here to save the day and save us quite a bit of time. Let's go again. X minus 4 squared.
Squared.
We know there's an x squared, and we know there's a plus 16. Negative 8x. And the answer to where did that come from will never change. Ask me 100 times, and all 100 times, my answer is going to be take red guy, take green guy, multiply them together. Negative 4x, double that, stick it in the middle. Let's go again. X plus 10 squared. X squared plus 100, and I leave a space. And in the middle, it's 20x. That was your moment, Hugo. You missed it. Want to go again? X minus 8. Quantity squared.
Squared.
X squared plus 64. Get the easy crap out of the way first. Take your low-hanging fruit. X squared and 64 are on the house. In the middle is a minus and a 16x. Got it? That I wanted to take 5 minutes to do because that skill is going to not be something I want to be getting in our way. I don't want to stop every time and say, where'd you get that 10x from? Or because the answer every time is going to be square, square, multiply, double. All right, let's get back to our math problem then. So we find ourselves now in the same predicament where we have to do square, square, multiply, double. So we know that we can copy down this x squared. And we know we can copy down this equals 7. And we know we can copy down this minus sign. But what we need is the answer to the math problem in the yellow box. And we just practiced that like 6 times. Perfect. X squared, because negative x, when you square it, becomes positive x squared. There's a 49 that's plus at the back. And there's a minus 14x in the middle. Why do I still have it in parentheses? Because you got to multiply it by this negative. This pesky negative right here says, whoa, 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 slow your roll. Like I got to distribute through everything. So let's clean this up. X squared minus x squared plus 14x minus 49 equals 7. And this is nice. And you'll see this in about a third of your problems. It actually isn't a quadratic at all because what happens to these guys? On. Leaving us with a nice old 8th grade linear equation. We have 14x equals 56. I added 49 to both sides. I divide by 14 and I figure out that x is 56 divided by 14, which is 4. Those are nice. And so our answer is 4, comma, something. And again, I'll ask you, how could I find the something? Plug it in. And there's no better place on the board of right now, of all the things on the television, there's no better place than right there. If you like extra work, you can go put it in one of the original equations, but why not take one that's already solved? Y equals the answer to the box. Put in 4. What's negative 4 plus 7? And you're done. That means that that hyperbola and that straight line will cross at the point 4, 3. Still good? Okay, let's take a look at the third flavor. These ones are, I think, the hardest, but I'm not really sure. I'm sometimes not the best judge of these things, you know? So the third type is this. And just out of curiosity, what's the top one? Straight line. What's the bottom one? That one's a circle. Good. So it's an elliptical equation when you have your x squared and y squared with an addition sign between them. It's hyperbolic, hyperbola if there's a minus sign in between them. Again, if you don't ever know that, you can still ace this chapter, this section, no problem. So let's take that top equation and do what we always do and get y by itself. Perfect. And I'm going to take that and I'm going to box it. And where am I going to put it? In place of y in the other equation. So follow the yellow arrow. It goes right there. So it's worth a step to just do don't do any math on this step. I don't mean to boss you around, but it's just not worth it. Yeah, Kyle.
Square root of use the bottom row when they do the same thing.
It wouldn't. Square roots don't work like that. It's a really good question you have. And my job would be a lot easier if the square root of x squared plus y squared were x plus y, but that's actually not true. Let me see if I could try to come up with examples of why that doesn't work, but square rooting, exponentiation, they get messed up when there's a plus or a minus in a problem. So the square root doesn't apply itself that way. For what it's worth, I probably would have asked or thought the exact same thing if I were sitting in your chair, but it doesn't work. So they are not the same. Good question. So let's go ahead and plus, and I'm going to put some parentheses here just because it's a habit. And then we need to, so we're going to square, multiply, double here, right? So we need to put a negative x plus 5 squared. All right, so let's square, multiply, double. So we get x squared plus what? Plus x squared minus 10x plus 25. Yes, and I don't know what I was talking about. I needed those parentheses. That would have been bad math to not put those. I was getting ahead of myself. So, and I didn't need them anymore because distributing a plus is a waste of time. So if the thing with the purple arrow had been a minus sign, then I would have kept the parentheses like here and here. But who needs them when you're distributing a positive one? So, so here we go. They don't this time, and that's why these I think are the worst. So we're stuck in a quadratic that we can't get out of. So x squared and x squared come together to make 2 x squared. The minus 10x stays the same. If we pull the 25 across, we get 0, and this is what our equation looks like. This is a different flavor of quadratic. This is not a double set of parentheses, what multiplies to this and adds to this situation. This is different. This is where, in a problem like this, you guys are all taking notes. You should write down this. If it looks like that, comma, use the GCF. This is not the normal type of factoring that you're accustomed to. This is a type of factoring where we pull out something that we can. What enables us to do this is the fact that that number in the back, the 25, got murdered off by the other 25, so we don't have to worry about that. These are actually a lot easier. What can you pull out of 2x squared and 10x? You can pull a 2, and you can also pull an x. That's the greatest common factor of them both. And what does that leave behind? X minus 5. All the x came out of the second one of the x's came out of the first one, leaving us with this. Bless you. So what we have now is a red factor and a white factor. And our job, as always, when we factor, is to factor with a purpose. And the purpose is to say, what can I do to make a factor equal 0? These are not upper level questions. What could I put in place of x right there to make that red circle equal 0? 0. It happens all the time. Because 2 times 0 is the only way to make it into a 0, right? So we have 1/2. And then, of course, what can I put into the white parentheses to make it equal 0? Wow. So we have figured out that our 2 answers to this problem look like this. I'll switch to green here. We have, well, that was odd. We have 0, comma, mystery. And we have 5, comma, mystery. And where, oh, where do we solve the mysteries? We plug it back in. And if we happen to have a box laying around, which I'm pretty sure we do, I'll have to scroll up, but I think we do. What a perfect place to put numbers. So like, let's go up to the box and let's put 0 right there. What's y going to be? Perfect. So we now know one of our answers is 0, 5. Sweet. Same second verse, same as the first. Go up to the box and change it into a 5. And if you put 5, what's negative 5 plus 5? That is 0. So our other solution is 5, 0. That means that that circle and that line cross at those 2 points. Got it? Okay. So that's 3 down, 3 to go. Let's see if we can make some headway on example 4. All right. And then we'll wrap it up. But we will not. I don't know why I was even contemplating the notion that we'd get through all 6 of these because I'm a fool. But let's start example 4. Get as far as we can get. Who knows? Maybe we'll get really far. This one I'm a little bit suspicious of. I was trying to write these last night between my algebra skills, my use of Desmos, and my puny little brain. I think I came up with 6 that have good integer solutions, but this one, the 3's got me a little nervous. Let's do this. So what do you remember going all the way back to example 1? What's our go-to for this? Just make them equal the same. Like this and this have to equal the same thing, right? So we just literally set them equal to each other. We say, hey, x squared plus 3, I need you to go ahead and equal 3x minus 1. Because if you both equal y, then you both equal each other. And now we do basic math. What's our strategy for this? You remember from a half hour ago, what do we do? Set everything on one side equal to 0, right? This is just a nice standard quadratic equation. So we're going to leave the x squared alone. We're going to pull the 3x over. We're going to pull the 1 over. And this is the result. And then we do my third favorite F word, which is factor. Tell me about my signs. 100% both have to be negative because they multiply to make a positive, which means they have to both be the same. And then if the number in the middle is a negative, there's no way that could ever happen if they weren't both negatives. So that's that sort of team effort that we use, like we play those signs off of each other. And what numbers multiply to make 4 and add to make 3?
Oh.
There are none. So I wrote a bad problem. I don't think this one works. This was the one that I knew was going to be a little sus. So yeah. So this would be a quadratic formula. You know that if we try all the numbers, I clearly meant for this to be a -4. So maybe I'll re-record 4th or 8th hour, but I clearly meant for one of these signs to be different. So anyways, can I just change it real quick? Can I call an audible? Do you care? And then I'll fix it for later. This one, I just had a Spidey sense vibe about this one. Yeah, so what I really wanted, take a look now at where I'm moving my pen. Well, here, let's do it this way. You see where I'm moving my pen? You see it? Change that in the original problem to a minus. Do you see now where I'm moving my pen? See it right there? Change that to a plus. You with me?
Yeah.
Okay, so now we're going to go down here to the problem. I apologize for this, but I just saw it coming. I saw the writing on the wall. If we change this one to a minus and change this one to a plus, now when we solve our equation, we get x squared minus 3x as I wanted, minus 4. And then I have to fix my signs. Got it? And now we need a positive and a negative, one of each, correct? And this is what I meant. What numbers multiply to make -4 and add to make -3? +1 and -4, resulting in success. So what makes that equal 0? -1. So I can put it like this, -1 comma blank. And what makes this one? Good, +4. And I ask you this again and again and again, where are we going to get those second halves? We're going to plug them in. And we don't have any boxy sort of things, so to speak, but we kind of technically do. We can put them wherever we want to. Let's just put them in here where the yellow circle is. Put -1 right there. What's 3 times -1? What's -3 plus 1? So our first answer is -1, -2. See where the yellow arrow is pointing? This time, let's put 4 in there. What's 3 times 4? What's 12 plus 1? And there's our other. So having said that, wow, we made it through 4 out of 6. Not bad. So you feeling it? Tomorrow we will conclude the notes. Should take about 10 minutes, and then I'll give you your assignment. So there you go. That is how you do nonlinears. Yeah. Thanks, buddy.